Through the history of man, the heart has always been ascribed with powers beyond its circulatory pump function. How did we develop our knowledge of the heart? Welcome to ReachMD Book Club. I'm your host, Dr. John Russell, and we're joined by Professor Rob Dunn, the author of The Man Who Touched His Own Heart. So, Rob, what led you to write this book?
I've been writing about and working on human bodies and the species they interact with for a while, and the more I've written about and thought about and worked on bodies, the more it's become clear how much we don't know about them still. And so I thought it'd be fun to take one of the parts of the body that we seem to think we understand the very best and sort of pick apart how we know what we know about it, what we don't know about it still, what these sort of residual mysteries are, then the history of how we've thought about that hunk of flesh through time, with the background, the subversive attempt in doing that to also let the reader think about ecology and evolution and how they bear on the way that their body works or fails to work.
So I was fascinated by the early forefathers of medicine and anatomy and their discovery of the heart's role. What are some of the things that stand out in your research?
Well, I think if you go way back to ancient Rome, to me, Galen is an amazing figure. A lot of these early doctors or scientists felt as though they were charmed from birth, that their chosen career was bestowed upon them by nature, and Galen was one of these guys. And he was just absolutely fascinated with bodies. And any way that he could look into them, think about them, see them, study them, he was all in. And to our great benefit, because he actually figured out, I think, for more than any other single individual, more about how our bodies work than anyone else. But he did it through every conceivable unorthodox means. And so one of my favorites is, at the time, it wasn't allowed to do human dissections. And so, he was really trying to figure out, well, how could he possibly get a good look into the human body? And there was a job opening to be the doctor to the gladiators. And to him, this was this great opportunity because the gladiators were always getting sliced and diced, and so you could have some chance to look into a living human body. And there was essentially a day when all of the potential candidates for this job would come forth and try out. And he really, really wanted the job, and so he brought with him a Barbary macaque. And he proceeded to gut the Barbary macaque and then tell the other doctors to be, look, if any of you guys can sew this up, you can have the job. And so he was kind of a wild man, but at the same time, incredibly creative as a scholar, incredibly perceptive. And he started to piece together, how circulation might work. And he was tangling with all sorts of ancient ideas, most of which were wrong. But he started to pull things together, and we tend to make fun of Galen because he got a lot of things wrong. But you have to remember that he was working in 100 A.D., and so given that was true, he got a lot of things right, is probably the better way to think about him.
I think after reading what you wrote about Galen, he is my new favorite. He was fierce. He was a leather jackety, kind of wild bunch kind of guy as an ancient scholar, so I love that. So when do you think the heart moved beyond kind of anatomy and physiology into cardiology?
Well, so I think a key moment was when Werner Forssmann, who's a doctor in just pre-World War II Germany, he was a low guy in a totem pole in a hospital, and he started to think about what you could do in terms of intervention in the body and in the heart. At first, just to see what was going on in the heart, but in the back of his head, he had the idea that maybe you could actually do something. And he was inspired by earlier work that had been done on horses, in which catheters had been inserted up the legs and into the hearts of horses to measure their blood pressure in the heart. And so he decided to go into his office and tell his boss, look, I'm going to try to send a catheter through a patient's vein and into the patient's heart to see if it's possible. And it was a teeny hospital, and a lot of what he'd been doing was, he'd been helping clean up rooms. He didn't have keys to the cabinet. He wasn't the guy that was going to get permission to do a great big new experiment. And so his boss told him no, and in fact his boss told him, look, Werner, I know your mom. If your mom finds out that I let you do this, I'll never hear the end of it. And so there's no way. Why don't you go try this on rabbits? And so Forssmann goes home and thinks about this a while, and then goes back to work, and he decides he wants to do it still. And so he convinces a nurse to let him do this procedure on her. And they have no idea whether it was going to work. Really, it was probably 50-50 whether she would live or she would die in this attempt in terms of their thinking about it. And so he does convince her to do it, and so they go down to the room in which they're going to try to do this catheterization, and she opens the cabinet and gets everything out, and then he straps her down, and it's a urethral catheter because it's all they've got. And so he gets her all ready, and then he turns around and he does the incision on his own arm and proceeds to shove this urethral catheter up his own arm vein toward his heart. And so she notices that he's done it himself, and she screams, but he keeps doing it, and he gets it to where he thinks it might be in his heart, which is when they realize that they're in a room without an X-ray machine. And so he unstraps the nurse, and now with this urethral catheter maybe or maybe not bobbing in his heart, he's got to walk down the stairs to the floor below to the X-ray machine. And they really don't know what's going to happen. And so they get down there, and one of his buddies is there, and his buddy tries to shove him away from the X-ray machine and pull the catheter out. They get in the room, they do the X-ray, and sure enough, it's almost at his heart, and so he gives it another shove and gets it all the way there. And so that really, I think, is the birth of cardiology for all practical purposes. And so in a way, it's like Galen. I mean, it's the same sort of leather jacket medicine in some ways. So there's a lot of leather jacketedness at the root of what we do and don't know and do to the heart.
And that's your title character. That's the man who touched his own heart, correct?
He is, yeah. And he went on to become sort of marginalized relative to what he wanted to do. I mean, he wasn't able to build on that surgery. You know, he went on to be a successful doctor, but he imagined that he would do each and everything to follow up on what he had started, and he didn't have the chance that he might have, which is our loss, I think.
And some other doctors then kind of figured out how to get dye into the coronary sinus.
Yeah, and so, I mean, many things build on that moment, you know, and so you start with a urethral catheter, and then you get to where we are today, when you can do almost anything through the core same procedure.
Cardiac surgery, where would you kind of ascribe, and I think the book opens with the stories of one of the first cardiac surgeries, correct?
Yeah, I mean, to my mind, one of the very first happens in Chicago in the 1890s. And to me, it's really amazing that it takes that long, because if you look at something like brain surgery, I mean, the very first brain surgeries happened thousands of years ago. And so if you look in early collections of skulls, there are skulls that are healed over from brain surgeries 5,000 years old. But the heart waits. And so until the 1890s, if you got stabbed in the heart, if something happened to your heart, you would go to the hospital, and, you know, nobody would do anything. You could listen to what was going wrong, and you could hope. In the World's Fair in Chicago in 1893, there's a guy named James Cornish, and he's hanging out with his friends, and it's a super, super hot summer. And one of his favorite songs comes on the jukebox, and he stands up, and all of a sudden he feels that he's been stabbed. And he falls down, and longer story short, he ends up at this amazing African-American hospital in Chicago, Providence Hospital, where a guy named Daniel Hale Williams had been training African-American nurses when nobody else would. And he ends up at the hospital, and at first he seems like he's doing okay, and then things deteriorate. And it becomes clear to Williams that either he's going to have to do something to intervene, or he's just going to watch Cornish die. And what's amazing to me is that until this moment, there have been hundreds of thousands of similar moments like this, where somebody's come in stabbed in the heart, and people have had to watch and hope that the patient heals. And for whatever mix of hubris and heroism, Williams decides to operate. And he does so in what's essentially a converted bedroom with no air conditioning, no antiseptic, nothing. And he cuts into the body cavity and looks at the heart and sees that the pericardium has been cut open, but not the heart itself, and looks at it, and the heart sort of spits back at him and stitches the pericardium shut. And amazingly, despite there being no antiseptic or anything, Cornish lives. He goes home. He actually gets stabbed again later. But that, I think, is really this really key moment in the story of heart surgery. Even though it's a modest surgery, it's just stitching the pericardium shut. It had been such a big deal to touch the heart for so long that doing so, you know, began this process when people could think about doing more.
You're listening to ReachMD Book Club. We're talking with Professor Rob Dunn, author of the book, The Man Who Touched His Own Heart. So then cardiac surgery, they develop the heart-lung bypass, and the whole thing of transplants I felt to be kind of a very, very interesting kind of part of the book. You want to expound on that a little bit?
For me, transplant sort of has two stories, and the story I think we hear more often is the story of the first transplants, and I talk about that. And it's a story of, on the one hand, sort of the beautiful power of technology and medicine. You know, the idea that we could take the heart out of one animal or one person and put it into another animal or person. I mean, there's something intensely powerful in that idea. And so I think there's an interesting historical story about how we think about that and the way in which it relates to, you know, our attempts to land on the moon and what we believe technology to be capable of in that moment. But the other story that to me actually in some ways is more interesting or differently interesting is that after the first transplants start to occur, and Christian Barnard does the first one in South Africa, and it's this incredible moment in which Barnard does a transplant from a young woman into this guy, Louis Washkaski, and he lives. And Lewis's wife thinks he's going to have the personality of a young girl, and he wakes up and he's just like himself. That's the moment we most often talk about. And Barnard goes on to be kind of like a celebrity, and he sleeps with movie stars, which his wife really didn't like.
And he really didn't earn the right to be the first person to do a transplant. It seems really clear in your book that there were a lot of other people who did a lot more kind of upfront work. Barnard just kind of said, well, I'm going to do it.
By the time Barnard did it, people had been working for a couple of decades to move toward the transplant and doing lots of careful practice in dogs. And by that point, there have been quite a few successful attempts in dogs. There had been a failed attempt to take a baboon heart and put it into a man in Mississippi. And people were, I think, rightly scared to move into humans until everything was just right. But Barnard had seen what was going on and thought, you know what, I'm going to do this, I'm going to do it for me, I'm going to do it for South Africa, and I'm going to do it first. And so there's more to the story, but basically he went for it, and he went for it really early. And the punchline is that Washkashki lives, like 18 days, and in fact in the next 5 years, almost no one lives more than a few months. And so in some ways what starts as heroic, this amazing transplant, is really one of the worst failures for a while in the history of medicine, I think. And some historians have suggested that in those first 5 years that the average recipient of a heart transplant actually lived less time than if they'd never received the transplant at all, which is a pretty strong indictment of what was going on.
But then the biologist in you probably was excited about the cyclosporin discovery, I would imagine.
That's right. So I'm trained as an ecologist and evolutionary biologist. So as a human, the powerfulness of the story of moving a heart from one person into another, you can't but feel some awe and awesomeness in that. But as a biologist, the other story that's fascinating is that one of the reasons these transplants fail for so long is that the body that was receiving the heart would reject it. It was like a giant pathogen that had arrived somehow right in the middle of the chest. And so what allowed the heart transplants eventually to take off was sort of more careful procedures, but then also this drug, cyclosporine, that suppressed the immune system of the person receiving the heart transplant. Cyclosporine is still used. And so it was this sort of miracle drug. And if you look at the number of heart transplants, very early on it goes up really fast, and then it stops. And then once cyclosporine is discovered again, it goes up until we get to the modern rates. But to me, the really neat thing about cyclosporine is that nobody studied why it worked for decades until just a few years ago. And a fungus biologist, as sort of a weekend hobby project, went into a collection of fungi that students had collected at her university, Kathy Hodge. And she thought, what would be more fun than going out and having dinner on the weekend? I'm going to grow this fungus that one of the students found in cow poop, in a beetle that was living in cow poop. And so she did this, and when she did, she figured out that this was, in fact, the same fungus that was producing cyclosporine. And the reason that this is interesting is that this fungus is a fungus that takes over the immune systems and brains of insects and makes the insects do its bidding. And so what it now looks like is that the reason cyclosporine works in the first place is that this badass fungus that takes over immune systems, and it takes over elements of the immune systems that are so central to functioning that it applies as much to our own bodies as to those of insects. And so we're actually now in our lab looking for new cyclosporine-like drugs out of this same group of fungi, with the idea that maybe we can jumpstart a new generation of some of these immunosuppressants.
And the last point that I'd like to hit on, and there's so many more other great stories in the book, atherosclerosis has always really been felt to be a 20th century Western disease, and you found it not necessarily to be so.
Yeah, this is a fascinating thing. There's so much about the heart that we just assume we understand, and then when you dig into it, it turns out nobody's looked. And so, the classic one, I think, is atherosclerosis, where all of modern medicine, we assumed it was this modern thing. And we know that cholesterol is part of what modulates its severity, as does what's going on with the immune system. But we thought all that was really modern. But then sitting around in museums all around the world are mummies, and mummies that people have recently figured out that you can send them through a CAT scan just like a person, and then look at their atherosclerosis. And the first mummies anybody ever looked at were Egyptian mummies. And the thought was that you put Egyptian mummies through the CAT scan, and that they would have clean arteries, and it would be a measure of how bad our living had gotten relative to the good old days of pyramids. But when they did that, what they found was that no, in fact, the mummies had atherosclerosis at levels very similar to what we see in, white dudes in New Jersey. and so this is a problem, right? And so what people then first said was, well, the only people who got mummified in Egypt were the fancy people, and maybe they were eating bad food. It wasn't hot dogs, but it was early versions of hot dogs. And so it sort of sat like that in the literature for a while, and then somebody said, well, there are a whole bunch of other mummies in museums. Why don't we look at those too? And so folks did. And when they did, what they found was that essentially all the mummies of all the cultures they looked at, including hunter-gatherers, including people who mostly ate seals, including people doing small-scale agriculture, they all had atherosclerosis. And so this really, I think, changes how we think about this modern disease of humans. I mean, first of all, it tells us that it's not modern. Maybe the degree is modern, maybe its manifestations have some modern elements, but it's old. But the other fascinating thing is that we now know that chimps don't get it. And so what this does is it pinpoints for us the likelihood that atherosclerosis is human, but not modern. And so then it begs the question, what is different between our ancestors and those of chimps, and at what point does this start to turn up? And it looks as though it's really a change in our immune system that makes us have overreactive immune systems in very specific ways. But I think the broader lesson is, we take very much for granted the idea that we understand what's going on with our bodies, and we're just still starting to figure stuff out. And for me, that was the real joy of writing about the heart, because what could be more central, more well understood, and yet the more you look at the heart, the more, its chambers present mysteries.
The book is The Man Who Touched His Own Heart, a great read. Professor Rob Dunn, thank you so much for being on the show. It's a great book for anyone to pick up and learn so many things that we don't know about the things we do every day in medicine. Thank you so much.
Oh, Dr. Russell, thank you so much. Pleasure to be back. Have a great day.
Take care. This is Dr. John Russell. You've been listening to ReachMD Book Club. To download this program or others in this series, please visit reachmd.com. Thanks again for listening.